Hey everybody, welcome to the first lecture for Chapter 13. We're talking about systems of equations. Let's get into it. So, one of the big things that we're going to be doing throughout this entire section is talking about what happens when you have more than one line. The last chapter we did was graphing a line, and so we have some idea of how to do that, but all of a sudden what's going to happen is we are going to be having a total of 2 lines appearing on our graphs. So here's one, there's another, and you can see when you have more than one line, it's totally possible for them to intersect at a point. So what we need to do is we need to figure out some ways of figuring out how to do that. For us, the first way is going to be graphical. Let me go ahead and start making a new graph. We're going to graph a couple of nice basic functions. I'm going to graph y equals 2x. I'm also going to graph y equals x plus 1. And we want to figure out where they hit. So let's start with y equals 2x. When I graph y equals 2x, I need the slope and I need the intercept. Remember that there's always a secret plus 0 if there's nothing being added to it, and so the y-intercept is y equals 0. And the slope of 2 tells me that if I move up 2, I'm going to move to the right 1. So I go ahead and I connect those lines, and I get y equals 2x. Now let's graph y equals x plus 1. So to graph y equals x plus 1, again, we need the y-intercept. The y-intercept is 1, so we put a point at 1. And what else do I need? I need the slope. The slope is also 1. It tells me when I move up 1, I move right 1. Well, we can see what just happened. The 2 lines intersected here at this point. The value of that point is 1, 2, which tells me that the x-coordinate is 1, the y-coordinate is 2, and if I replace x and y with 1 and 2 in either of my 2 equations, I should get a true statement. Plugging this into y equals 2x, does 2 equal 2 times 1? Absolutely. Plugging it into y equals x plus 1, does 2 equal 1 plus 1? Absolutely. Here is the x value, and here is the y value being plugged into the 2 equations. And we can see that we get true statements both times. That means it's a solution to both equations. You can see a solution to both equations by an intersection on the graph. Alright, let's go ahead and try this again with a little bit trickier lines. Let's graph y equals 1/3 x plus 1. So as I'm graphing y equals 1/3 x plus 1, I'm reminded that the slope is 1/3 and the y-intercept is 1. So I go ahead and I put a dot here at 1, and a slope of 1/3 tells me to go up 1 and to the right 3. I'm going to go ahead and connect these two. Now I need another equation. So I'm going to graph y equals x minus 2. So we'll do that here in red. So that has an intercept of -2 and a slope of 1. And as I connect these, uh-oh, where did they hit? They didn't quite hit all the way over at 5. They didn't quite hit all the way over at 4. They hit somewhere in between. Well, graphically speaking, we can do no better than guessing. So what we need is a much better way of thinking about this. That won't happen until the next chapter. Let's do one more that will work. Let's again graph y equals 1/3 x plus 1, but instead of graphing y equals x minus 2, let's graph y equals x minus 1. See what happens then. So just like before, for 1/3 x plus 1, we start at 1, we move to the right 3 and up 1, and we connect them to make our line. For y equals x minus 1, we start at -1, and we start moving up 1 and right 1, and connect them to make our line. Aha! These two intersect at a nice point. We can look at this point and see that it's 3, 2. Now let's plug them into the two equations. Does 2 equal 1/3 of 3 plus 1? Well, since 1/3 of 3 is 1, and 1 plus 1 is 2, we're good. And does 2 equal 3 minus 1? Oh yeah, that's easy. That's totally true. So we can see that sometimes you can tell by graphing what the points of intersection are, and sometimes you can't. Now that we've seen a couple of ways of figuring out if two lines intersect, let's see what happens when two lines don't. So I'm going to graph y equals x minus 1 and y equals x plus 1. Looking at y equals x minus 1, we see the slope is 1, and the intercept is -1. So I'm going to plot the 2 points and connect them. Now I'm going to graph y equals x plus 1. Again, the slope is 1, and the intercept is +1. So plot 2 points and connect them. We remember, since the slopes are the same, that means the lines are parallel. And what we see is one of the two possibilities for when lines are parallel. In this case, we have that the lines never touch. So when lines are parallel, they might never touch. If they never touch, there's no common solution. Remember, every single point on any line is a solution for that line. If there was a common solution, there'd have to be a point that was on both lines at the same time. And since these two parallel lines never touch, there is no such point. One other thing can happen. Let's graph y equals x plus 1 and 2y minus 2x equals 2. Well, if I set up my axes and I start graphing these, starting with y equals x plus 1, I go ahead and I make my graph. And I'm going to try to be a little cavalier. I'm going to pick a point on my graph here, 1, 2, and just ask if it works in this graph. Does 2 times 2 minus 2 times 1 equal 2? Yeah, it does. That totally works. Well, that means that 1, 2 has to be on this line as well. Well, let's check another point. How about 0, 1? Does that also work? 2 times 1 minus 2 times 0, does that equal 2? Well, that's 2 minus 0, that does equal 2. Wow, 2 of the points on this line work for this other line. And we know that when we have 2 points on a line, that gives us the entire line. So if I connect those 2 points, I get the graph of this one. Uh-oh, they're the same. Not only are they parallel, but they're totally the same line. That means all points are solutions to both. So here's a case where we have lots and lots of points, giving us solutions to both. So the possibilities, and you can see, are when we have two lines which are skew, that aren't parallel, they're going to intersect once. When we have two lines that are parallel, two things could happen. One is they might never touch, in which case there's no solution at all. And the other thing that can happen is that they always touch, in which case there's an infinite number of solutions. So that's it. That's our lecture for the first part of Chapter 13. Next time we're going to learn the substitution method. Go ahead and do the homework that I've listed in the recording description. Thanks.